Hi, I'm Vlad, and I have to say, these on my face, these are tears of joy for being the speaker, the lucky guy that follows Mark Richard and is just before Dylan beat him. So this is happiness right here. Yeah. So I'm here today to tell you all about how to build your own well, internet-connected search assistant. Those are very big words. We're not going to build something very big, but we're going to build something really cool, just like you've seen on TV. All right? So specifically, what should we build? Well, personally, I'd like to have some sort of an assistant, yeah, a co-pilot, other than that I can ask about any events that have occurred after September 2021. Yeah? Specifically, why September 2021? Well, because that's the cutoff date for the training data for the GPT models. Yeah, they know mostly everything that happened, everything that was on the internet before September 2021, and almost nothing that occurred. So I want to build something like this, to be honest. This is a Jupyter notebook connected to an instance of GPT-4 with Azure. I'll show you how in a moment. And I'll ask it, okay, give me the list of speakers for CodeCamp Yash 2023, which is right today. Hopefully this is the right conference. Right, and I'm sorry, as an AI developed by OpenAI, currently don't have real-time information, blah, 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 blah. It cannot do it. Cannot do it. Whereas something more, let's say, internet connected, such as BingChat, let me ask it the same question. So give me the list of speakers. I'll just copy-paste this like a real developer and paste it here. Enter, enhance, so we can zoom in. It's thinking. That's what AIs do. They think. Yeah, so it seems to be searching for something. CodeCamp Yash. There are Mark Richards. Boom. Venkat. Boom. Join. Boom. Alexandru, Dylan, Vlad, it got them right this time. So to be honest, when I rehearsed, it had something like a 50% success ratio, which is reasonable, but it got them right. Right, so this is exactly what we want to build. And how do we build it? I have no idea. Hopefully we'll find out, right? Right, so, but in order to do, oh my God, I can fall down here. Sweet, sweet. So I move a lot during my talks, so you might have more entertainment than you bargained for. Right, so how do we build this? Right, we're going to think step by step, right? You know, think step by step, so like every AI influencer on LinkedIn is posting big lists of 10 things you don't know about ChatGPT, 10 things that indicate that you're using ChatGPT wrong. You know those? And thinking step by step is one of them. And well, it's one of them for good reason. It actually improves the responses that you get from large language models. And I'll explain why in just a moment. And it also works for humans, right? So let's think step by step. And let's start by thinking about what large language models are. All right. So what do we know? Well, we know they're trained on massive amounts of data. So something like the whole internet. We can ask them questions. They seem to answer. They sometimes lie. Yeah, they hallucinate. They know I'm speaking about them. All right. The AI is trying to shut me down. All right. So fingers crossed this will stop. Otherwise, I prepped. It's not AI, right? It's me. Well. Would have been cool though, right? Skynet. Right, so AIs hate him. What was I talking about? We do know they're able to not just manipulate space and time, but also generate text, right? Like huge amounts of text. And, well, but have you thought, how do they do it? Well, I'm gonna share a little secret. They do it with a for loop. So I wrote this cool code that you probably can't see in the back, because I'm using a very hip new presentation tool that cannot do bold in code segments, and I can't use this presenter with it, but it's really cool, I recommend it. So this is mostly pseudocode, but also Python for AI. Yeah, and I'm sure most of you have already read this, but what's going on over here, right? So, at every given, let's say, an input text, we have this for loop, and at every point, at every step in the for loop, and I'm going to get these bottles out of my way because, again, falling hazard. At every point in the for loop, they just predict the next word. They predict the next word. They add it to the input. And they use that to predict another word, which they add to the input, and they use that to predict another word, and so on and so off. Right? So it's not necessarily about thinking, but more about predicting the most likely word that follows a given block of text. And of course, those of you in the know will say, Vlad, they're not words, they're tokens. Yeah, I know, but it's still useful to think about them as tokens, but also as words. I'll show you how in a moment. And also, the fact that they don't necessarily predict the most likely next word. They sometimes fluctuate in order to make the text interesting. Right? But in broad terms, this is it. This is AI in a nutshell. And now, armed with this knowledge, let's talk about why thinking step by step works. This is a bit of an intermission. But the thinking step by step part comes from a research article from last year. And can you read this? I hope not. Yeah, who here can read this? Wow. I should have made this smaller. Anyways, so basically it prompts. This is a, let's say, chain of thought technique, yeah? It helps the model fall into the pit of success. Yeah, how does it do it? Well, we do know that based on a given text, they forecast, they predict the next most likely word. So if you just ask them for an answer using a... Told you. I haven't moved this, to be honest. A juggler... Okay, so the question being something like, a juggler can juggle 16 balls. Yeah, some of them are blue, some of them are not blue. How many are blue? And the model, when prompted to just give the right answer, it says 8 because it's a word, it has a probability of occurring after a given text. Yeah, why not 8? Which is obviously wrong. Whereas using a chain of thought technique, yeah, it starts by, it's not a he. There are 16 balls in total. Half of the balls are golf balls. And with every word it outputs, it increases the probability of getting the right answer, right? Because it increases it more clearly defines the context used to get an answer. Does that make a bit of sense? Just a bit of sense. Right, but that was an intermission. This is not about what we're going to do, mostly. This is about what we're going to do. So, a first idea, we know GPT models have been, so GPT-4 and 3.5, specifically OpenAI's versions, have been trained on, data up until September 2021. We want to be able to ask them, recent questions. Why don't we just retrain them? Right, it makes sense. It's been done once, why not again? Well, so let me maybe clear this up by giving you a quick visualization of a training pipeline, of how training a large language models looks like. And I thought about, showing various diagrams, and I think this is the best one. So let me walk you through it. Right? So basically, what do we do when we want to train a large language model? Well, first, we just take everything on the internet, right? This monstrous blob of text. Yeah, good, worst, horrible stuff on the internet. And we train a base model. Yeah, this base model, it takes thousands of GPUs, months to train. It's very expensive because it has to ingest a lot of data. And we get this unsupervised learning, this model that can complete text. Yeah, it can associate concepts. It can generate cohesive text that makes sense. Yeah, no bad grammar. It can generate all kinds of instructions, including how to make bombs, which you may or may not want your model to output. Right? So, bad. So then what do? Well, then you try and drive it towards answering questions that you want to answer in the way you want to answer them, right? So maybe don't tell the user how to build a bomb, right? Just say, as an AI model, this is bad. You should feel bad. Don't do it, right? But we'll get into supervised fine-tuning in a moment. This is just a helpful visualization. And now, maybe just to drive my point, here's a quick difference between base models, the ones trained that just want to autocomplete text, and chat models, the ones that we get from fine-tuning them, especially with some reinforcement learning. So from a base model, if you were to ask it something like, how does Hamlet's famous monologue start? What does it want to do? It just wants to complete documents. So, good question. Here's two more. What is the opening line of Romeo's soliloquy in Act 2, Scene 2 of Romeo and Juliet? What are the first words out of Tears and Rain? Because, Blade Runner was a great movie. And so on. It starts just running around in circles because it wants to complete documents. It doesn't want to answer your silly questions, humans. Whereas an assistant model, well, that one's more potty trained, let's say. Right? So, I did not mean to speak like this. I'm sorry, this is 10,000 steps a day, they say, and I'll be responsible for 7K. Right? But I can just improvise, if not. Right. So, and it starts explaining something about, I actually prompted this to use a chain of thought so that I would get better answers. So this is the whole famous monologue, often referred to as the to be or not to be, whatever. And it gives me the right answer, right? So, as opposed to the base model. So, we might conclude that it doesn't really make sense to do a full retrain, because just one piece of trivia, Facebook's, Meta's Llama models. I read something that the first Llama model, I think it was the 7B version, cost something like 5 million, or all of them, not sure, who knows, cost something like $5 million to train. And honestly, if I had $5 million, I would spend them otherwise, not just training a model. So maybe you as well. Okay, but we've seen that retraining is hard, training it from scratch. Maybe we take an existing base model and we fine-tune it. Just give it the updated info so it can answer questions. Well, by the way, this is how Llama 2's training pipeline looks like, and you'll see they have this pre-training stage, which the text is a bit small, but they get pre-training data, they use self-supervised learning, and they get the base model, which is then fine-tuned on the one hand with pretty much high-quality examples of questions and answers, so it knows what we expect of it. And then it's also tuned with reinforcement learning with human feedback. Basically, you have people evaluating multiple answers from the same model and telling it, look, I prefer this over these two. I prefer this, I prefer that. And incidentally, this is how you get, and apparently humans love confidence. We eat that thing. So we love it so much that we train models to give us wrong answers in a very confident manner. So this is, you can thank RLHF for that, right? So here's how a fine-tuning dataset looks like, by the way. This is a snapshot from the OpenORCA dataset. It's an open dataset. It's hosted on Hugging Face. It's based on Microsoft's ORCA paper, in which they argued that they can increase the performance of, well, let's say, lower models, 13 billion parameters, by just fine-tuning them with high-quality data. Maybe high-quality data that they obtained from other better, more expensive models such as GPT-4. Right, so that was really cool. Just use a more expensive model that OpenAI spent millions of dollars training to do your own fine tunes. So yeah, yay science. So and by the way, this is the entirety of the columns in this data set. So they have a system prompt, something like giving it gives the model a bit of context, right? So you are an AI assistant that helps people find information, blah 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 blah. A question, you know, John was a terrible writer. Wow, that's so mean. To practice, his teacher suggests blah 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 blah. Think step by step. Think step by step. And the answer is step 1, step 2, step 3. And the model sees this and it starts to associate. Look, for inputs like this, I need to give outputs like this. As an AI model, I cannot answer this because that would be offensive to John. Right, so 2 issues, right? One, gathering a data set of all text on the internet is not a trivial matter, right, if you've tried it. It takes a lot of time. You can't really do it, I don't know, on the fly. It's expensive. And on top of that, once you have that data set, fine-tuning still takes an amount of resources that you may or may not be able to spend on this, or may not want to. Right? You still need some or more GPUs to do the fine-tuning. You still need to wait for a while. Not that straightforward. So basically, you wouldn't get this real time. And I'd really want to build such a thing real time, almost real time, let's say. Right? So it's back to the drawing board. Well, here's an idea. And Gabriel, can I single you out and ask that you play a ding whenever you see this light bulb? Like now? No, man, with your phone. Right, next time. But there will be more, I'm testing you. So, idea. What if we include the info in the prompt? Right, so like in, like in school, right? You raise somebody up, okay, tell me, what's the capital of Vietnam? I don't know, well, try this, the capital of Vietnam is, right? You give the answer to somebody and then say, okay, answer from the thing that I just gave you. Huh? Pam, pam, pam. This should have been aligned, but you know, computers are hard. All right, so let's talk a bit about context window sizes, right? Which is totally unexpected, I'm sure. Remember this code? Have you heard about context window in the context of a large language model? Yes, definitely. All right, so basically, that's the size, or let's say the size of an input an LLM can handle, right? So regarding this code specifically, you might think that this is the size of the input variable, right? But no, this is the size of the input and output, because remember, at each step, the model is using all the input and the text that it has predicted to predict the next word, next token, right? So if you see something like a context size of 4,000 tokens, is the color making someone's eyes bleed? Yes? Should I change it? Yes? All right. Sorry for this. I had a wild hunch, you know, I did. But let's say, so Paris. Who loves Paris in the winter? Better? Yeah, man, but those were some very nice blues. I'm sorry. All right, but basically, you have this list of models, right? You have Llama 2 from Facebook. That one can only take about 4,000 tokens. And same with GPT 3.5 Turbo, right? GPT-4 is at 8,000 tokens. Then a couple of months ago, OpenAI released a new version of GPT 3.5 that can handle even more text, right? So they get more and more capable of handling large blocks of text. Even though, unfortunately, the best model ever, GPT-4 can only take 8K tokens, and GPT-4 32K is not really available to a lot of people. Yeah. But just as a recommendation, if you ever need to ingest large amounts of tokens right now, so without waiting to be whitelisted or something, Claude 2 is really, really cool. It supports up to 100,000 tokens. It's made by somebody other than OpenAI, so it's not really as good as GPT, but it's quite capable, right? So, but you know, they're so small. I mean, if I want to put all the internet in the prompt, it will not fit. It just will not fit. So how do we fix this? Yeah, how do we make it fit? Well, you know, I heard there are some product owners in the house, so please don't forgive me. I had one requirement, and this was not what I requested. Thank you. So, an idea, yeah? Why don't we send it? What if we don't send it everything, right? But then, how do we know what to send it? Right? How do we know what to do? Well, we put only the relevant info. We send it the good stuff, of course. So now the question is, what's the good stuff? Well, this pattern is called RAG, from retrieval augmented generation. Yeah, so basically, maybe it's simpler to explain with with a sample. I forgot about this slide, but this is cool. So this is what I got from Bing Image Creator when I asked it, okay, Bing, I want you to draw a diagram that illustrates the RAG pattern. And it researched the entire internet. It spinned a lot of hamsters, and it gave me this. And I don't know what this is. It makes no sense, you know? But I like the colors. There's some really, the blues, really, I think they complement my shirt. That's why I picked it. So, and also, I also included this to make a point that RAG is not as complicated as this makes it look like. So, then what is it? Well, and right now I know everybody's reading that instead of listening to me, and I can't have any of that. Right, so what's RAG about? Well, imagine you have a list of results, the best results you've got. Yeah, you know them. How do you get a large language model to answer questions that for which the answers can be found in those documents? Well, a simple way to do it would be to prompt it like this. Something like, do you want to have a context in which you read and I read out loud and we'll see who finishes first? Go. So you are a search assistant that helps users find information from a series of curated documents. The user just asks you this question. You need to think carefully and find the best answer to the query. Do not make stuff up and answer using only information from the following documents. You finished first, didn't you? Sorry. Well, and that's how it works. That's all you need. So you can prompt the models, hey, I know what you're thinking. Sorry. The problem with this approach is that, to quote the Stack Overflow blog, the quality of retrieval augmented generation is only as good as your search results. Yeah, and also the what? Also about it's related to the quality of the model you're using. Yeah. So they're actually experimenting with this. I was reading a blog article from a couple of months ago where they're trying to update their search to include AI because everybody's trying to experiment with that. Right. So so how do we get the best search results? Well, here's another thing. Specifically in the RAG pattern, a very popular approach is to ditch the lexical search that we're all accustomed to and use semantic search. So what do I mean by that? You know, plain old search. You have a query, it's split into words, you see the most important words, you match them with a database index that you've built or with an Elasticsearch or with something, don't care, with something. Yeah, but they don't look at the meaning. You don't look at the meaning. Maybe you look at the synonyms, maybe you look at similar words, similar queries, but you don't look at the meaning. And that's the gist of lexical search. Whereas for semantic search, instead of just indexing the words for text, you try to extract the meaning, the concepts. And you do that by calculating some vectors of numbers called embeddings, with specialized models, embeddings models. So what do these embeddings do? Well, basically, imagine an array of numbers that for two similar documents, and by similar I mean that talk about similar concepts, that have some similar ideas, they're quite close to one another, by calculating, I don't know, various metrics such as cosine similarity. So if you manage to calculate the vectors of numbers for each and every one of the documents you index, documents you want to search, then when you have a query, I don't know, have no query ideas whatsoever apart from, what was that sound I heard from Gabriel, right? No other queries ideas. You can also calculate the embeddings for the query and then match them to your database. Stickers. I like stickers. Right? So this way, you can see which documents are the closest conceptually to your query. And you can just include those in the prompt. Now, of course, this is an oversimplification. Your documents might be higher than the prompts can take. Maybe you have a large language model that you're using GPT-4. It only supports 8,000 tokens. That's not necessarily 8,000 words, maybe less. So maybe your document has 16,000 words. How do you do that? Well, maybe you split it into multiple parts, and then you calculate the embeddings for each of those bits. Or maybe not. There are several strategies, and maybe they're a topic for another talk. Right? But that's the general idea. But now, we've been discussing about lexical search, about semantic search, and come to think of it, we don't need them. So here's a bit of a tweet from a guy at OpenAI. So last year, they released their embeddings at a ridiculously low price. So OpenAI also has an embeddings model. They deprecated it this year and released a new one, so that was fun. You would have to redo your whole embeddings if you had done them when this was posted. But basically, they calculate that the size of the internet being 10 at the power of 11 pages of text, you would only need $50 million paid to OpenAI to embed the entire internet and then apply semantic search on the internet. And he asks, who wants to take on Google? So here's a brilliant idea. Why not just use Google? Thank you. Brilliant. Bravo. We can just use Google. Why do we need the hassle of maintaining an embeddings database and stuff like that? We can just scrape the results. They'll never know. So let's see how this works in practice. I'm actually going to show you the code that does that. So, and I still have some time. So this is boring stuff. You're not going to want me to go through this. But basically, this is me connecting to an Azure OpenAI deployment. Notice the Azure API type. And defining some helper functions. They don't matter very much. So how are we going to do this? Well, first, you've seen BingChat. It forgot. Well, you've seen BingChat. Its first step was to optimize my, chat command, let's say, to a Google query. So this is what I'm doing right now. So right now, this is all this is me coding, right? But I'm not coding with instructions. I'm coding with words. So I'm telling it, okay, convert. You're gonna get an instruction. Convert this instruction into such a brilliant query that I'm gonna find the best result if I search for it on Google. And don't format it in any way, I said. And then I watched in horror as it would format it with double quotes. So I also mentioned not even surrounding it by double quotes. And it listened. Just return the raw query. So if we run this, let's see what happens. It's using Can you see this? I'm guessing it's visible right in the back. Right? It's using CodeCampyHash 2023 speakers list instead of give me the list of speakers for CodeCampyHash. So what did it do? It detected that, okay, the important event here is CodeCampyHash 2023, so it should add that first. That's what Google wants. And then, okay, also some context. About CodeCampyHash, I want the speakers list. Okay, so this is a big chunk of code that was not generated by AI. It was painstakingly written by a human and then copied by another one from Stack Overflow. So works. Right, I updated it a bit. To be honest, I deserve some credit, but it's not. It just works. Let's not think about it. So this fancy get Google results for optimized queries, and I'm printing them, and you'll see it seems to work. Yeah. So the first page is CodeCampyHash, and then it's another CodeCampyHash page, something on YouTube that I think you, Mark, posted. I saw that video. Yeah, it's on Google. Right, and also Vox Days. Ooh. Right, so once we get the link. No, I meant that as you know what I meant. Once we get the URL and title, we're gonna use them to download the page. So again, this is all pretty basic code, but I want to highlight just a few things. So the downloading of the page doesn't matter, anyone can do it. But then you get a very big page. So if we look at the source, I'm printing this, I'm printing some stats over here. The unprocessed page weighs in something like half a megabyte of text. And that translated to tokens is about 147,000 tokens. Which, you know, is a lot. GPT-4 won't be able to handle that. So what I'm doing over here is just extracting the text. And for this, I'm using a very cool HTML to text package that its sole purpose in life is converting HTML text to Markdown. And I love Markdown because as opposed to, you know, regular text, you can have structure in it. Yeah, you can have hierarchy. So you have chapters, subchapters, and so on. And turns out this is really important for our large language model that's being asked questions about the text structure. Right? So I'm telling it, okay, ignore the links, don't care about links right now. Don't care about images, don't care about mail tos. If you find the table, keep it though. Right? And this gets us at 26,000 bytes and 579 tokens. 5,000, 1,100, 1,000 is bigger. Yeah, almost 6K tokens. Yeah, and it kind of looks like this. You know, just stripping everything. We're not gonna look at this, right? I just realized that I haven't mentioned anything about the difference from, you know, the difference between words and tokens. Do you want me to get to that, or do you want to just see the bot? See the bot, right? Brilliant, me too. Yeah, so a token is a word, to be or not to be. This is translated into some tokens. These are the tokens you see. Some of the words are one token. Some of the words are more than one token, that's it. Also, they translate to numbers. There. All right, so back to the bot, the chatbot. Well, this is a bit more complex, right? So I'm basically using the same pattern I mentioned before, the RAG pattern. I'm telling you, you are a search assistant that helps users find information. You will receive a list of documents in this format. You need to think step by step, because who doesn't? Yeah, don't make stuff up. If you don't know the answer, say so. Answer in the following format. Now, you can see this is optimized for sending multiple documents. At one point, I thought about showing how to process multiple documents, but then I figured it would distract from the focus of the talk. So that's why we only get one document. But this is a great way to get attribution. You've seen when I asked BingChat something, it provided me with a list of URLs from where it got that information. And if you want to convince it to tell you where it's got that information, you need to include that info, right? So, and I'm also prompting, this is the query, this is title, URL, and page content. I'm doing one more interesting thing here. Yeah, you see, in case my page is too big, right? So GPT-4 can take something like 8,191, presumably, or 90 tokens. So I'm trimming my prompt to 8,000 tokens so that it has some space to answer me in case I'm send it too big of a page, right? And I do that by just converting the prompt into tokens, just cutting the tokens after anything after 8,000 and then decoding it into a text. And this isn't really relevant. These are just some helper functions. And this is the mighty chatbot. How does it work? Well, I'm defining conversation. Flicker. Right? But maybe we can see also how it works. Yeah. Still visible? I think so. Right? So this is how the API works. It's OpenAI API. It expects a series of messages, right? From various roles, you know, user, system, assistant. System messages are used to define basically the general behavior, some template of how the model should react, and then just a series of messages. Now, one thing to keep in mind is that these models are stateless, right? They don't remember anything. So if you want to be able to have a conversation with one of them, you need to send it the history of what you talked about over and over and over again. And this is what I'm doing here, right? I'm defining a conversation, then in a for loop, told you for loops are the best, right? I'm getting a response and the usage. The usage is how many tokens I'm spending. I'll show you how much in a moment. Yeah, printing the message, appending the response to the conversation, you know, because I'm going to send it again, reading an input from the human, printing that, and so on and off. So this is the list of speakers. Cool. What are they talking about? Right. So you also see the amount of tokens. So right now, we had the initial prompt at almost 6,000 plus 112 completion. So right now, it's GPT-4. Told you, it's really slow thinking. And yeah, the topics that they're discussing. And you can see it kind of mixes up the master classes with the talks. But we can ask it for just the talks, please. Talks, please, no master classes. All right. So does that count as having fulfilled this talk's purpose? Kinda. We can chat more, of course. One more thing. What time is Vlad speaking? Who knows? Right? If I ask it, how much time do I have until I'm done? It cannot, well, I'm already over it. Yeah, from 15 to 15:45, and oh my, look at the time. So I'm gonna stop this. I'm gonna say thank you, and I'm gonna show just a bit of a teaser of what you can achieve if you give a model access to tools. It has access to the current time, right? So you can do a lot of things by connecting models to tools, including formatting your hard drive and wreaking havoc on everything. So looking forward to see how the next 2 years will be. I'm not gonna talk more about this. I'm gonna put the slides and this notebook on my Substack tomorrow, so you can go check it out if you're interested. Thank you so much for being here and for supporting me.